In this lesson, we will be adding and subtracting rational expressions that have the same denominators or common denominators. Since rational expressions are really just kind of fancy fractions, we can use the rule for adding and subtracting fractions from basic math to help us to combine rational expressions. Notice the first one, you have a over c plus b over c is equal to a plus b over c. This is saying to us that if we want to add two fractions, they have to have the same denominator. In this case, they have a common denominator of c. And the way that we combine them is to actually add the numerators, or the top parts, together and place that over the common denominator. So the adding only happens in the top and the denominator is carried. Same thing with subtraction. A over c minus b over c. Two subtracting fractions, they have the same denominator or common denominators. We rewrite the common denominator and the subtraction happens in the numerators. A subtracts with b. So it says here that we will add or subtract numerators and place over the common denominator. Factor the numerator and denominator, then divide out common factors. That's really the process we'll use for adding or subtracting. The first part is applying the rule, and the second part is the simplification of the final answer. In our example here, we have add or subtract, and we're going to write the answer in simplest form. So let's take a look at this first one. We have 11x over 2 plus 3x over 2. So we're being asked to add these together. So I'm going to take 11x, and then this is saying add the term that follows. So I'm going to add 3x, and I'm going to place this all over 2. Now 11x and 3x are like terms, so I can combine them together to get 14x over 2. And then 14x divided by 2 leaves us with 7x as the final answer. If you want, you could factor to get there. 14x is really 2 and 7 and x over 2. Those divide out for 1, and 1 times 7 times x is 7x. That's an alternative way to get the same answer. If we look at the second example, we have 5c over 22 plus 7c over 22. So we're going to say 5c adds with 7c, because this is saying add the second term. And then it's all over 22. And those are like terms. So 5c plus 7c is 12c, all over 22. And then we can factor to look for common factors. 12 is 2 times 6, and 6 is 2 times 3, and then times c. And then 22 is 2 times 11. So you can see here that there are at least there's one common factor of 2. And then our final answer on this is going to be 2 times 3, which is 6 times c, which is 6c, all over 11. In the next example, we have something that looks like the previous one, but you'll notice here that when we take 5c and add with 7, place over 22, 5c and 7 are not like terms, so you cannot combine them together. And so in this example, that would actually be the final answer. In the last example on this page, you can see that we have a common denominator that actually is a binomial. So in the top, I'll do what it tells me. It says take x squared. Then it says add the 5x and 6. So we're adding 5x, which looks like plus 5x. And we're also adding positive 6, which looks like 6. X squared plus 5x plus 6. The common denominator is x squared minus 4. Now in the top, x squared plus 5x plus 6 cannot further simplify because there aren't any like terms to collect. And I rewrote the bottom. So at this point, we would go to factoring to try to simplify. Notice the top is a trinomial that begins with a 1. So remember, that's a factor pair shortcut. 1 times 6 is 6. The factor pair is 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. So we can factor the top part of this with x squared. We'll get x and x. And then plus 2 plus 3. The bottom, the denominator, is actually a difference of 2 squares. What do you square to get x squared? X times x, right? What do you square to get 4? 2 and 2. So remember, you'll have 1 minus and 1 plus, and now we'll divide out a common factor of x plus 2. That divides for 1, and we end up with x plus 3 over x minus 2. And I've talked about this before. You cannot divide out the x's because you can only divide out factors. X is part of the factor x plus 3. So x is just a term in that factor. And then x minus 2 in the bottom. X belongs to x minus 2 in the binomial. And so you cannot just divide the x's out of there. The question might be, when could you do that? An example of when you could do that, just to kind of give you a sense of when that could happen. Let's say you had something like x times 3 over x times negative 2. Now this would be the case where the x's could divide out because the x's would be factors. That's not what's happening here, but that is an example of when you could divide those x's out. And in the last two examples, we have looks like subtraction. So in our first one, we have 33x over 11x minus 1 subtracting 3 over 11x minus 1. And I'll do what the subtraction of fraction rules tells me to do. I write the first numerator down, 33x, and then do what this says, right? Minus 3. In the bottom, the common denominator is 11x minus 1. I notice in top that 33x and 3 are not like terms, so I cannot gather them together. So I've simplified the top as much as I can, but I can factor now to simplify the entire fraction. 33x and 3 have a common factor of 3, and that would be 11x minus 1 in the top. The bottom does not factor, it's just 11x minus 1. But you may notice that the top and bottom both have the binomial 11x minus 1. So it divides by itself entirely for 1, and then an overall answer of 3. In the final example, we have two fractions subtracting. They both have the same denominator again. So the process is that we rewrite our first numerator, 5x squared plus 9x. Then we do what the problem tells us to. It says subtract these two terms. So I'm going to subtract 2x. Here. Then it's telling me to subtract negative 2. Think about that. Subtraction of negative 2. Remember how that works. That actually gets changed to addition. Remember when we minus a negative, we add the opposite instead. So that's why subtracting a negative 2 turns into an adding 2. And then the common denominator is x plus 1. Now what I notice in top here is that I have some like terms, these x terms. So I'm going to gather them together. 5x squared plus 7x plus 2 is what I get in top, and then all over x plus 1. Now, I need to check to see if I have any common factors between the numerator and denominator. And the way we figure that out is we actually end up checking to see if there's a factor pair that works for this problem. So let's see here. 5 times 2 is 10. And if I say 1 and 10 and 2 and 5, I notice that 2 and 5 actually adds to 7. That means that I can break the trinomial apart. So remember how we do that. We take 5x squared and rewrite it as 2x plus 5x on the middle term. Then we're going to factor by grouping. So we're going to get x, 5x plus 2, and then plus, notice here that we don't appear to have anything in common, but 1 is always in common. So I'm going to do a plus 1. And so this factors into 5x plus 2 and x plus 1. So I'm going to go back to my problem. The top factors into two binomials, 5x plus 2, x plus 1, all over x plus 1. And then I'm dividing out common factors, and I end up with 5x plus 2. So these are all examples of adding and subtracting rational expressions with common denominators, and it works like basic fractions work. Just got to keep your eye on all the signs of the terms, and then you have to remember your factoring techniques to simplify in the end.